everyone, and welcome to the lecture on Introduction to Keras. Keras is a neural network library, and we will use this library to build different neural network models, and it runs on top of TensorFlow or Theano. And the official documentation for Keras is found at keras.io. You can read more about it or any specific details in the documentation here. As I mentioned, Keras is a high-level neural network library written in Python, and it runs on top of TensorFlow or Theano. We have already installed TensorFlow. The next thing we will do is install Keras. And to install Keras, we can use the pip install command. If you are using Windows, open up your command prompt, and for Mac Linux users, open up your terminal and simply type pip install Keras with upper K, and this should install the Keras library on your machine. So it might take a few seconds to install Keras, and once you finish your installation, restart your Jupyter notebook and follow along. And for our neural networks, we'll be working with a dataset known as the MNIST dataset. And this MNIST dataset consists of handwritten digits. And here is the URL where you'll find the MNIST database. It consists of 60,000 training datasets and 10,000 testing dataset samples. Okay, here I have the URL for the MNIST database of handwritten digits. It consists of 60,000 training and 10,000 testing sets that we can work with for neural networks. Okay, and here are the links for downloading the training and testing datasets. I have already done that and saved it in a certain path. I'll follow that. I'll provide that path to you so you can use it for uploading. And you can read more about the MNIST database if you are interested here. Okay, I'll go back to my Jupyter notebook and start our lecture by importing the libraries that we need. As usual, we start by importing numpy as np, import pandas as pd. We have our matplotlib for plotting, and we have our magic function to see our plots in Jupyter notebook. Okay, and the next thing we need to import is Keras. For that, we simply type import and then Keras. Oh, this is lowercase, sorry. And once we import Keras, here you see we already have TensorFlow installed, so it will be using TensorFlow as its backend. And we also need to import the MNIST dataset from Keras dataset. For that, we simply say from keras.datasets import MNIST. Run it. Okay, now we are ready to use Keras. Let's start by uploading our MNIST datasets. And I have saved this. Our MNIST path, as I have saved it in a file named mnist.pkl.gz. And this MNIST dataset is a very large dataset. Okay, what we'll do next is I have provided this for you, so you can simply put this package where your Jupyter homebook is located, and we will simply load our MNIST dataset by using the load data method. Okay, let's do that next. So MNIST has a load data method, so we'll use that method to load our dataset. So simply call the load_data method and then pass the path for our dataset, which is MNIST_path. And we'll save the dataset in 4 variables. xtrain, ytrain, xtest, and ytest. Let's do that. So xtrain, ytrain, and then xtest, ytest. Okay. The reason why I'm using xtrain and then ytrain, so the training datasets followed by the testing datasets, is that here I mentioned that the training dataset has 60,000 samples and the testing dataset has 10,000 samples. So that way, by appropriately naming our variables here, these two variables will have 60,000 datasets, whereas the testing variables will have 10,000 datasets. Okay, and we'll confirm that later on by calling the length method on them. Oh, here we have an error. We don't need this quotation mark here. Let's run it again. Let's run it again. So if you are running this for the first time, it might take a few seconds to upload. Okay, now that we have uploaded our dataset, let's check out the shape of our xtrain, ytrain, xtest, and ytest variables. Okay, let's start by checking the shape of xtrain. Run it. So here the shape is 60,000 by 28 by 28. What does this mean? As I mentioned, our training dataset consists of 60,000 samples, and each dataset consists of handwritten digits from 0 to 9. Okay, and each digit is 28 pixels by 28 pixels. Okay, so that's what this means, 28 by 28. We have 60,000 samples, and each sample or each digit is 28 by 28 pixels. Similarly, if we print the shape of our ytrain, it's a one-dimensional array. And let's check out the shape of xtest. Xtest.shape. Okay, and for our training datasets, we have 10,000 samples, and each sample is 28 by 28 pixels. Okay, and you can check out the shape of each of our datasets by simply using the type function and passing your variables. For instance, the type of xtest is a NumPy array. Similarly, if we check type of, let's say, ytest, or this is type, it's a NumPy array. And we can also use the length function to find out the length of our training or testing datasets. For instance, we can find out the length of our ytrain dataset. It's 60,000, whereas if we check the length of our ytest dataset, it will be 10,000. So these are some general information about our datasets. Next, let's check out some of our digits. Okay, let's explore some of our training datasets, for instance. So we have our xtrain, our training dataset, and let's check out the shape of the first digit. Let's see what the first digit looks like. Okay, so we'll index it 0, and this is what it looks like. It's an array, and we mentioned it's 28 by 28, right? So that's what we have here, 28 by 28, and most of them are zeros. Most of them are zeros, and wherever you have a number, that means that's where you'll see the digits. Later on, we'll have matplotlib and draw a figure and explain what these numbers are. So this is in RGB. Again, in RGB, the numbers range from 0 to 255. Okay, so when you look at the figures, those will be the darker areas. The numbers will be the darker areas for our digits. Okay, So this is our array for the first record in our X-train dataset. The shape of this array is 28 by 28. Okay, 28 rows by 28 columns. Similarly, you can check out any of your X-train dataset by simply indexing. Let's say if I pass 34, you'll see an array 28 by 28. Okay, that's what it looks like. I'll just comment this out, and next let's explore our Y-train dataset. So our Y-train will be, remember, these are the MNIST dataset consists of handwritten digits, right? 0 through 9. So our Y-train dataset will consist of any one of these numbers. For instance, if we say Y-train, and let's check out the first 5 results. So we have an array. The first number is 5 in our dataset, and then 0, and then 4, 1, 9. Okay? And if I say Y-train, and if we try to check out the first 20 results, we have the digits 0 through 9. Okay, that's what our Y-train dataset looks like. Similarly, we can check out what our Y-test dataset looks like. Let's index the first 15 numbers. We have an array, and those are the first 15 digits in our Y-test dataset. And we can also find out how many times a certain digit appears by using the NumPy's unique method. Let me show you an example. So we can say numpy.unique, and then we can pass our, let's check for our Y-train dataset first. So we can say numpy.unique and our Y-train, and we can pass another attribute known as return counts, and we can set that to true. That way it will tell us how many times a certain digit appears. So unique will only display digits 0 through 9, right? Those are the unique numbers. And the return counts will display how many times those unique digits appear in our Y-train dataset. Let me run it and show you the result. So here we have our unique digits 0 through 9, and this is the number of occurrence of each digit in our Y-train dataset. So on average, each digit appears 6,000 times, right? 6,000. And if you add up all of these numbers, it should give you 60,000, right? That's our training dataset. And if we check out the unique number of occurrences for our Y-test dataset, Y-test, and then return counts, let's set it to true, we get the digits 0 through 9 and their occurrences here. So the occurrence for each is 1,000 times on average, right? Almost 1,000 times. And if you add up all these occurrences, it should give you 10,000, which is the number of our training dataset. Testing dataset. Okay, so we see that there is an even distribution of our digits in the training and testing datasets. Okay, that's important to remember. Now that we have some general information about our MNIST dataset, let's use matplotlib to plot some of these digits. Okay, so let's first start by setting the figure size, plt.figure, and we'll pass the fig size attribute, and I'll set it to be, let's try 7 by 5 maybe. We can adjust this later on once we see what the figure looks like. Okay, and I'll set the axis to be fig.addSubplot, and then let's use 1 by 1 by 1, And we'll use the IAmShow method for our image. So we'll set the image to be IAmShow. And let's check out our X-train dataset. And let's see the first digit in our X-train dataset. And for color map, let's change the color map to gray. Okay, so we'll set the color map to gray. So we'll take our image and let's set interpolation to nearest, and then nearest. Finally, we can call the show method and see what it looks like. Okay, nice. So it looks like the first digit in our X-train dataset is a 5, right? That looks like a 5. And remember, each image is 28 by 28 pixels, right? And here color map is gray. Let me copy this, paste it here. By default, we have the jet color map. So if I remove our color map, we'll get something that looks like this. So that's the default color map. That's the default color map, jet. And earlier, if you remember, when we check the X-train dataset, we have a 28 by 28 array, right? So these numbers, wherever you see these numbers, 253, 242, 195, and so on, it represents these dark areas in our figure. Okay? So all the zeros indicate this area, whereas wherever you have a number, you know, that's represented by this. That's what those numbers mean. And in a grayscale, it would be, the values will be between 0 and 1. So if you divide all of this by 255, the numbers will be between 0 and 1. Okay, and that's what will be represented here. Okay, close to 1 will be dark color and close to 0 will be white color. Okay, so let's check out some more figures. Let me copy that, paste it here, and let's check our X-train dataset at index 7. We have the number 3, and this time let's check our testing dataset. Let's see the first digit in our X test. It's 7. If I copy this, and if we try to see the fourth digit in our X test dataset, it's 0. So this is a general background information about our MNIST dataset. And in the next lecture, we'll start building models and try to calculate the accuracy of our models in predicting the digits. Thank you everyone, and see you at the next lecture.